So hello and welcome to a very short tutorial on how to generate regularly spaced points in an area. This is very important for several reasons. For example, you could use the skills acquired here to design soil or rock sampling grids, which helps you create a systematic sampling pattern. For example, you could decide to sample every 50 meter by 50 meter. It also ensures consistent coverage of a target area and reduce or minimizes sampling biases. So, apart from designing soil and rock sampling grids, it is also useful in planning drilling campaigns. It helps you to design regular collar position across a deposit. Another application could be to prepare a grid of points for spatial interpolation. So it is a very handy tool that has a wide range of applications in geology, and it is quite easy and straightforward. Okay, I have navigated to my favorite location using Google Earth. You already know how to use one of the web map tags in QGIS. Um, I'm just using this Google satellite. Of course, you know how to use one of the many tasks you have here. You just go to web, come to quick map services, and then you have options that you can pick from. So I have navigated somewhere in Nimba, which is my favorite spot. So I will be using this place as my area of interest. But as you should know, you also have the possibility of importing a shapefile and using the shapefile as your area of interest. I don't have a shapefile right now, so I will just generate a polygon here covering this location to use as my shapefile. So the very first thing you want to do here is go to layer, uh, go to create layer. Here you have several options. For example, you could create a geo package layer. You could create a new temporary scratch layer. As I said, if you choose the option, QGIS will display it, but it will only be generated on the fly, which means as soon as you shut down QGIS, that data is lost. But for the purpose of this tutorial, I will go to new shapefile and create a new shapefile. So here I will name it, but before naming it, I want to save it in my working folder. So I will navigate to my working folder, which I is in my C drive, and I think I name it sampling points. So I will name it uh, sampling sampling points. Of course, the name could be drilling points or whatever, depending on what you intend to use it for. So I will name it sampling points and then click save. The next thing is the geometry type, because this is like my study area I'm creating, so I will use polygon. The next one is your coordinate here. Go uh, I will navigate to a projected coordinate system that covers Liberia, which you are familiar with. So far so good. Um, Text type, I will leave the rest as default and just click OK. Okay, so here we have another layer in our layer panels. So the next thing you have to do is to ensure your toggle editing is on. You could just put it on from here, or right click on the layer you just created and select in some instances, okay, here is it, and select toggle editing from here as well. It works both way. So as you can see, once our toggle editing is active, it gives you the option to create this polygon. It gives you the option to create vector too, but we will be creating polygon. So I will click in here. Once that is done, our cursor changes into a format that allows us to um, create a polygon. So I will just try to make it cover the length of this place. So I will click and click in 4 different corners to create like a rectangular shape. So I will come here, I click for the last time, and then right click on your mouse and then click OK. So as you can see, our study area has been defined. So the next thing we want to do here is go to processing, select toolbox, and then right in here, um, regular, because we want to generate regular space points. So we'll write in here regular, regular, and select um, regular points on a vector creation. So once that is done, input extent. Input extent will be the extent of a study area. So ensure that you select the sampling points we just created. So as you can see, once you select that, the coordinates of the polygon we just created will automatically fill into this column. So the next one is the point spacing. Uh, this this ultimately depends on you. By default we have 100 meters here, so it will be 100 meter by 100 meter. So if your intent is to create your points at an interval of 100 meter each, you can keep it this way, but let me just reduce it, for example, to 50 to a 50-meter interval. So the next thing I will want to do here is to ensure that I get my coordinate reference system correct. I started using this projected coordinate reference system, so I want to maintain this so that it will be uniform across what I'm trying to do. So I will select the QGIS 1984 UTM Zoom 29. The next step is to save whatever points we are creating in our work folder. So you already know how to navigate to your work folder and save whatever data you want to save. So I will be looking for my sampling points, and then this will be I will name it regula regular points, and then click save. Once that is done, keep the rest as default and then run. So I will close. Now you can see it has generated our points at 50 meters interval. So here we are. Let me reduce this further so that I can see the full extent of my grid. Oh, I have made this too small. Let me increase it further. Uh, okay, I think this looks better. So the first thing here we want to do, the first thing we want to realize here is that some of the grades went beyond the extent of our area of interest. So we will be making that correction. But let's first of all check the attribute table of the grades we just created. So all we have here is the ID. We have nothing here like the coordinates for each of these points. So the first thing I want us to do here is to ensure that we only keep the drill points that are, or the sampling points that are within our area of interest. To do that, we'll use a tool called clip. So type CLIP and make sure you select this clip tool that says clip a vector layer using the feature of an additional polygon. As soon as you hover your mouse over, you should be able to see the description. So I will double click it and you will see vector overlay clip. Now input layer. So our input layer is our regular points we just generated, and our overlay layer will be our um, area of interest or our study area, which is our sampling points. Once that is done, okay, you could also save this output in our work folder. So I could just name this as clip points, clip points, and then click saved. Oh, okay. Click points and click save. Make sure all these inputs are there. So in the first input layer, you have regular points. The next one, the overlay, is your area of interest or your study area. So now I will just run. It's giving me some warning about no spatial index. I don't think it will affect our output. So let's uncheck our earlier regular points. So now you can see the ones we just generated falls entirely within our study area. So the next thing here is it is not useful in this way because we don't have coordinates assigned to each of the points. So if you wanted to send people in the field, for example, to go and collect samples from these points, how do they locate the various points? So to get this done, what you have to do here is let's go right click and go to our table of contents. Once again, you only have the ID here. So let's go to this tool called Open Field Calculator here up here. Click on it and then it opens. So the first thing we want to generate is our X coordinates, and then upper field type change to decimal numbers. Then write the expression here. Expression is a very important part of QGIS. It enhances the output of QGIS software to almost an extent that it can almost do anything any other software can do. But it can be a lot more complicated. But in this case, this is just a very, very basic expression we need to write in order to generate our coordinate system, our coordinates for the various points. So all you have to do here is to type the dollar sign. And once you type the dollar sign, expression is invalid. So add X. Once I add the X, the warning that the expression is invalid now disappears. So definitely our expression is valid. Now I will click apply. So it has generated our X already. The next step is to generate our Y coordinates. So you just write in Y. Make sure you change, okay, you maintain decimal degrees, and then change the X here. Write the same dollar sign, in fact, and then write Y, and then click apply. So I will just cancel this. So if you check now the attribute table, you see we have our ID for each of the sampling points, and we have our X and our Y. Now you can now easily send anybody to the various locations to generate whatever data you wanted them to generate. So the easier thing to do is just right click here, go to export, and click save feature as. So you could decide to save it as a shapefile, but in this case I will just save it as a comma separated value, CSV. Go to file name, and I will save it as sampling points. Click save. It is already in the correct projected coordinate reference system. Now all you need to do is click OK. So we have generated. If I just click here, it will take me to our working folder, and here is our CSV file. So let me open this CSV file and let's see how it looks. Okay, here we are. You see our RD for each of these sampling points, and then we have our X and our Y. So you can just give this CSV file to whoever is going to feed, and they will be able to identify the locations of each of the points. So basically, this is what we had to cover, and I hope it proves useful. So thank you, and then let's look forward to uh, our next step.